Now we'll do the same example using mesh analysis. First, I need to define my mesh loops. At least initially, I'm going to do that by killing the sources and finding enclosed non-overlapping areas. So this current source becomes an open circuit. There's a resistor there. There's a resistor up here. The 9-volt voltage source becomes a short circuit. Resistor here, and the 6 amp current source becomes an open circuit. There are 2 enclosed non-overlapping areas. So my mesh loops are going to go around the perimeters of those. I'll call this mesh loop little I1. It's different from capital I1. I'm not worried about that one yet. And then I'll have a mesh loop around here, which I'm going to call little I2. Now I need to define constrained loops. Constrained loops account for the currents through these 2 current sources. The loops are arbitrary. They just have to pass through the current source, and they have to total the actual magnitude of the current and have the same direction. I'm just going to make a loop around here that's going in this direction. That's 18 amps. So in here I have 18 amps going this direction, which is what I want. And over here I'll make a loop this direction, 6 amps. So now that matches the magnitude and direction of this 6 amp current source. Now I do KVL around each of my mesh loops. So KVL for loop 1, I'm going to follow the direction of I1, and I'm going to set my voltage polarity such that I1 enters the positive voltage terminal all the time. So if I start down here, I have 6 ohms times the only current going through that is I1 plus 9 volts due to this voltage source. Then that brings me to the 12 ohm resistor plus 12 ohms times the sum of the mesh currents. So I1's entering the positive terminal and I2 is entering the negative terminal. That brings me back to my starting point, so that equals 0. Now let's do KVL around loop 2. This time I'm going to be following I2, and I'm going to set up my voltage polarity such that I2 enters all the positive voltage terminals. So this is going to be the voltage polarity that I'm going to use for the 12 ohm resistor. This is going to be the voltage polarity that I use for the 4 ohm resistor. I've switched polarities on the 12 ohm resistor between this KVL and this KVL, but that doesn't matter. Ohm's law will keep everything straight. So starting down here, I have 4 ohms times I2 is entering this positive terminal. The 18 amp constrained loop is entering the negative terminal, so this becomes a minus 18 amps. Now I see the 12 ohm resistor. I2 is entering the positive terminal and I1 is entering the negative terminal. Now the voltage across the 4 ohm resistor is 4 ohms times the sum of the currents. I2 is entering the positive terminal, and this 6 amp constrained loop is also entering the positive terminal, so that becomes a plus 6 amps. That equals 0. Now we need to write an equation for I1. I1 is positive this direction. I don't get to change that polarity. So the current through this 12 ohm resistor is the sum of all the mesh currents going through it. So I2 goes in this direction, I1 goes in this direction. So capital I1 is equal to I2, which is the same direction as capital I1, minus I1, which is the opposite direction from capital I1. Those are our 3 equations and 3 unknowns. I can solve those for I1.